The Big Bang. We all heard of it. One point with infinite density exploding into the universe we live in today. The question is, where did the Big Bang happen? The answer is rather complicated, so make sure to stick to the end. Let's go back in time to where the theory first emerged. In the 1920s, astronomers like Vesto Slipher and Edwin Hubble noticed that distant galaxies were moving away from us, and the farther away a galaxy was, the faster it retreated. A Belgian physicist realized what that meant. Run the expansion backward, and everything converges into a single, unimaginably dense beginning. In the 1940s, George Gamow and his collaborators predicted that this fiery birth should have left behind a faint afterglow, still detectable today as microwave radiation filling the entire sky. Now let's go back in time even further, to the beginning of the universe. Picture the universe today, filled with galaxies scattered across unimaginable distances. Now, start rewinding. As you rewind, the galaxies drift closer together. Distances shrink. The whole cosmos begins compressing, like footage of an explosion played backward, everything gathering inward instead of flying apart. Rewind past the point where the first heavy elements, carbon, oxygen, iron, existed. Those elements were forged inside stars, so before stars, none of them exist yet. Only hydrogen and helium remain, drifting as vast, dim clouds. Keep rewinding. The clouds thin out and lose their shape, spreading into a smoother, hotter haze. Rewind past 380,000 years after the beginning, and something changes abruptly. Atoms come apart. Electrons that were calmly orbiting nuclei get stripped away by the rising heat, and the universe turns into an opaque plasma, a fog so dense that light cannot travel more than a short distance before scattering. This is the last moment light manages to escape freely. Rewind past it, and you rewind past the origin of the cosmic microwave background itself. Keep going. The plasma gets hotter and denser by the second. Rewind past the first few minutes, and nuclear fusion runs in reverse. Helium nuclei break apart back into individual protons and neutrons. The universe is now a blistering soup of raw particles, too hot for any nucleus to survive intact. Rewind past the first second, and even protons and neutrons stop existing as stable objects. The universe becomes a churning bath of quarks, electrons, photons, and other fundamental particles, all packed into a volume, shrinking faster than the eye could follow if there were an eye there to follow it. Continue rewinding, and physics starts running out of solid ground beneath it. There may have been an extraordinarily brief period before all of this, called cosmic inflation, when space itself stretched at a staggering rate. What caused it? What came before it? Or whether before even means anything at this point are questions physics has not yet answered with confidence. Run the clock back far enough, and Einstein's own equations predict a single, infinitely dense instant. Most physicists suspect this isn't a real object you could have stood next to. It's more likely the sign that our equations have finally reached the edge of what they know how to describe. And that is where the rewind has to stop. Not because we hit a wall we can see, but because we hit the edge of the map, the edge of time itself. So, where did the Big Bang actually happen? Not at some scorched crater floating in an otherwise empty universe. Not off in a distant direction you could point a rocket toward. It happened in the same space you are occupying right now, and in the space occupied by every galaxy your telescope will ever find, because all of it, every last cubic inch of the observable universe, was once part of that same searing, shrinking, impossibly dense beginning. The Big Bang isn't a place you missed. It's the place you're still standing in, 13.8 billion years later.